Hello, everyone. My name is Gaurav Mittal, and I work as Senior Security Data Analyst at Zoom Video Communications. Today, I will be presenting on Beyond CVSS, leveraging data analytics and AI for asset-centric vulnerability management. So let's go over our agenda. Today, we'll discuss about the current vulnerability management, how teams are using different approaches to prioritize the vulnerabilities. And CVSS approach is one of the approaches which is used by all the companies. So we'll discuss on that. After that, we will discuss on how CVSS approach is different than asset-centric approach, which is our topic of discussion today. And then we will deep dive into asset-centric approach, which is one of the approaches used by companies these days. And we'll understand like how we can use AI models for asset risk scoring, challenges associated with it, and some of the case studies. So let's start with the big picture. The volume of current vulnerabilities have exploded in recent years, and you can see it from the graph that vulnerabilities are increasing from 2015 till 2025. So in 2024, we already saw 40,000 new vulnerabilities, which is a 38% of jump from the year before, and the highest ever recorded number of vulnerabilities ever. Now we are in 2025, and till September 25, we have already seen 32,000 vulnerabilities. And if we go by this pace, we will surpass the last year's vulnerability data. So the problem isn't just the volume of the vulnerabilities, it is also the security teams which are overwhelmed with number of alerts and fatigue of the alerts, right? So research shows that about 12% of vulnerabilities marked critical actually represents a serious threat, exploitability threat in the wild for all the companies. That means most of the critical vulnerabilities which companies are getting might not be that important. But with this approach, teams needs to focus on the vulnerabilities which are marked as critical or high at their priority, and teams usually burden out with those work. So finally, the backlog. So no organization can realistically patch tens and thousands of vulnerabilities. Most of the teams can only remediate a fraction of vulnerabilities, which leads them to delay, misprioritization, increase in the business risk. This is why we need a smarter way or a smarter approach to patch the vulnerabilities. So just to give you the context, enterprise companies usually have 100,000 plus machines with them. And if each machine get 100 vulnerabilities in a month, you can just like multiply it and see how many vulnerabilities security teams needs to work in a given month. So now moving on to the next deck, where we will understand about the CVSS approach, the traditional approach which is used by all the companies to patch the vulnerability. So let's start with the basics. CVSS stands for Common Vulnerability Scoring System. Usually, this is the default way for most of the organization to prioritize the vulnerability. It gives every vulnerability a score from 0 to 10 and usually group those vulnerabilities into critical, high, medium, and low bucket. So there are like a lot of vulnerabilities and usually teams cannot focus on all the vulnerabilities. That's why CVSS approach gives a number, and based on that number, a vulnerability is tagged into a critical, high, medium, or low bucket. So on the paper, this looks very simple and standardized. But the problem is CVSS approach is very, very static. It does not change based on the environments. And it treats every vulnerability the same and no matter where it sits. So a good example of that would be a CVSS score of 9.8 vulnerability on a test server may get patched first. Meanwhile, a CVSS of 6.5 vulnerability on a production financial database, which stores a financial and secret data of the company, could be ignored. The reason is CVSS score on the very server which holds financial data is very, very low. So there's an issue of misalignment and misuse of the resources, higher risk exposure, and the key takeaway is CVSS alone does not reflect the business risk. So again, we need to come up with a smarter way, which we'll discuss shortly. Now, I would like to discuss the problem with CVSS-only prioritization. So first, it ignores asset value and the business context. What does that mean? CVSS doesn't know where the vulnerability lives. For example, I will use the same example again. A CVSS score of 9.8 vulnerability on a test server may look very, very urgent to all the teams, and they may run behind that vulnerability to fix it. But a CVSS of 6.5 on a financial database, which will be technically a medium vulnerability, might not be alarmed to those teams to work on. And if that vulnerability is exploited, it can be a catastrophic for the company. They may lose a lot of important data, customer data, and whatnot. Next, it does not account for exploitability in the wild. A vulnerability might get a score of critical, but might not be active exploit, or there is a low likelihood of attack on that. So CVSS does not provide us the likelihood of the exploitability. At the same time, a medium CVSS score vulnerability can be exploited in the wild by the ransomware groups. So it does not account for the exploitability in the wild. Third, it creates alert fatigue and wasted resources for the teams. Teams end up in patching everything critical first, often wasting time on low value issues. And this leaves truly business critical risks which are under addressed. And analysts might burden themselves to keep up with tens and thousands of vulnerabilities. And usually, security teams are very small in most of the companies, and in enterprise companies, security teams can be up to like 300 to 400 folks. That is a big number, but most of the companies really have less than 50 folks in the security org. So, moving on to the next slide. Here is a quick picture of the traditional view, which is CVSS approach, and the asset-centric approach, which we will discuss shortly. So just to give you and tell more about in a nutshell, asset-centric approach will consider all the business context of the asset. We can also get threat intel information on it, which will easily help us to prioritize vulnerability based on the real information, not partially based on CVSS scores only. Yeah, so now I would like to tell you some of the business impact of misprioritization. I will come up with a lot of stats and numbers, so please hang on tight with me here. In many organizations, critical vulnerabilities persist for far longer than they should. For instance, critical flaws typically takes 4.5 months to get remediated, which equates to around 174 days on an average, far beyond what organizations plans or expect to patch. During this window, attackers have ample of time to discover, exploit, and escalate inside the network. This is underpinned fact that 75% of newly disclosed vulnerabilities are exploited just within 19 days, with the quarter being weaponized on the very same day. That is very hilarious and huge. These delays drastically increase breach likelihood. Alarmingly, 60% of cybersecurity breaches stem from unpatched vulnerabilities and softwares, and 80% of the breaches can trace back to an outdated or unpatched system. Not only this, but it also exposes businesses to hacking, but they also escalate compliance risk, especially when regulated data is involved in companies. A compelling real-world example involves the known exploitable vulnerability, which is also known as CAV vulnerabilities. Over one-third of organizations faced at least one CAV vulnerability in 2023, and yet more than 60% of the known vulnerabilities were not remediated within the mandate timeframe. And I'm getting all this data from the very powerful references which I've mentioned in the end of the deck. In short, misprioritization of vulnerability isn't just inefficient, it is very dangerous. It extends exposure window, empowers attackers, increase breach odds, and jeopardize the compliance posture. So we need a smarter way to patch our vulnerabilities. And now we will discuss about asset-centric vulnerability management. So we can assume this approach considers a lot of data from a lot of different angles, and it will consider risk of an asset, all the information we can get on a vulnerability. So prioritization on this vulnerability is done by the value and the business context of an asset. I will discuss them in detail. Second, it also gives us information of a particular vulnerability, whether it is a threat intel, whether there is a threat intel on this vulnerability, or there is an likelihood of for the vulnerability to get exploited. And last, we can get inputs of all the information which we are getting from the CVSS approach. So again, CVSS approach is one of the element to this model, but not the entire thing. So there is a paradigm shift with this approach. Instead of asking, how severe is the vulnerability, we need to ask how severe a machine or an asset is for an organization where a particular vulnerability sits. In the old approach, we get panic after listening, okay, this vulnerability is 9.8 with a high critical severity, and we immediately get panic regardless of where it sits. But with the new approach, we will evaluate the business context, and we'll focus on crown jewels first. Like, let's say a laptop of my CEO is more important than a laptop where I'm doing a development job, right? So, like this, we can score machines based on the criticality where the important services are running, and so on. And we can also see what are the vulnerabilities present on a critical machine or on a non-critical machine, which we'll discuss shortly. So let's understand how we can build the asset criticality model and approach. So there can be multiple inputs to it. First, we need to understand the asset criticality, which will tell us the business impact, whether a machine on which services are running is a revenue generating system, customer facing application, or compliance critical database. Next, we will also understand that the different kind of data is stored on those machines, whether a machine holds PII, financial records, intellectual property, or the regulatory data. And last, for asset criticality, we can also understand if a machine is internet facing, it is exposed to different networks or not. And based on it, we can give a score to a machine. But we won't stop here. We will add more information to the vulnerabilities which are sitting on those machines. So we can tie real-time threat intelligence data to the vulnerabilities which are present in the machine. So that can again be one of the inputs. And last, we can also get a lot of like security context for specific machines. So there can be certain machines which are sitting behind 3 different layers of security. And there can be a critical machines which is not under any security layer and which have like a lot of important data of an organization. So based on this, we can prioritize our vulnerabilities. We can prioritize the number of assets which are important to our organization, and then we can go and patch them. So this is an asset first approach, which fundamentally change everything, how we collect the data and we act on it. So usually when we go by CVSS approach, there are certain data sources from where we get the data and tie that back to the vulnerabilities we have in our machine. But with this approach, we need to build different pipelines to gather the data on asset criticality, threat intelligence, some of the security context, and probably we can keep on increasing more features to it for us to get the right information. So moving on to the next slide, where we will understand why asset-centric AI prioritization is important. So traditional vulnerability management is like having a brilliant doctor who can diagnose every disease, but does not know whether they are treating a marathon runner or they are treating someone with a heart condition. So what it tells, the context of a situation changes everything. First, AI will understand, AI should not only model vulnerabilities which we get from the CVSS model, but it should also tie and train its model based on the information which is available on dark webs, or if there are any chatters going around a particular vulnerability on web, right? So using AI, we can do that. Second, business impact is more important than a raw CVSS score. So one of the academic research reveals that fixing a vulnerability just because it is assigned a high or a critical CVSS score is equivalent to randomly picking a vulnerability in white or a vulnerability randomly. In the real world, in real world, there are only finite number of resources to patch a vulnerability. So it is not possible to apply equal number of protection to all the assets, and requires a company to have a prioritization program to prioritize the vulnerabilities. And the problem which we face in scaling. So right now, as I told, like companies usually have 3 to 50 folks in the security team, and it is very difficult to patch all the vulnerabilities by themselves. So we can securely use AI tools and AI models to scale and patch the vulnerabilities and give us the prioritization on which vulnerabilities to patch. So probably we can get that information from AI in very minimal amount of time, probably less than 5 minutes. Once we know the scope of the assets which needs to be patched, then it will become very easy for any company or team and ask their teams to patch those vulnerabilities. And next slide, we'll discuss the asset-centric data modeling. How data modeling can be done for the asset-centric approach. First, as I discussed, asset criticality is a very important factor. First, what does the asset mean to a business? We need to understand that. If it is tied to financial data or a regulatory compliance, so we can give that kind of data to our model, and we can change the scoring of a machine based on it. Example, a misconfigured S3 bucket with PII data is much bigger risk than an outdated internal wiki server, right? Second, asset exposure. We need to understand if asset is exposed to internet or not. And based on that, we can do the multiple layer segmentation and give right score to an asset. Third, vulnerability severity. So again, CVSS data still matters, but it is only one ingredient to this model. It gives us the raw technical data about a vulnerability and the severity data we get. Then we can tie it back to the threat intelligence data. Is the vulnerability really exploited in while? Is the vulnerability a CISA CAV or not? A medium CVE with exploitability available in while is more urgent than a critical vulnerability which is not exploited in while. And last, we can also understand if there are any compensating controls which is tied to that CVE. A CVE on a server is protected by a strict firewall or not, and so on. Now we will discuss on the different algorithms which we can use to train this model and get this rich data. But before going forward, I would like to show you a diagram of this approach where we can give multiple inputs to an AI algorithm. And based on it, we will get a critical score or a high, medium, low, critical score of a machine. And based on it, we can send immediate alerts to the teams to patch those vulnerabilities or prioritize them in a lower bucket based on the data we get, right? Right, set the right SL expectations and also update to our executives. So I will give a couple of seconds to go over this deck and understand how an asset-centric model can be built. Okay, I will move on to the asset models, AI models, which can be used to build the asset-centric AI algorithm. So first is the supervised machine learning algorithm. We can leverage historical data of vulnerabilities that were actually exploited versus that were not, and map them to the right asset types. This will allow the model to learn pattern. For example, a CVE in a VPN appliance might be exploited more frequently than one in the printer server, even if both have the same CVSS score. In effect, supervised machine learning helps us to predict future exploitability within the context of business classes. Next, we can use unsupervised machine learning model. We often does not have labels for all the vulnerabilities, so clustering comes into the place. By grouping vulnerabilities across similar asset classes, we can detect hidden patterns of risk, such as clustering of misconfiguration or workloads or shared libraries. This is especially powerful in a zero-day or emerging vulnerabilities where historical exploited data is very rarely available. Next is the graph-based AI model, and this is my favorite. So cyber risk is not just about a single asset, it is about how many assets are connected with each other. With this model, we can stimulate attack path and blast radius. Let's say if a web server is compromised, we will know all the impacted downstream databases, customer records, and applications impacted by it. This gives us a systematic relational view of risk rather than treating vulnerabilities in isolation. And last is NLP for threat intel, which is very important. So natural language processing allows us to parse and vendors advisories and all the data available on web. Then we can map that textual information to a specific asset category. For example, NLP can detect that a chatter about a VPN appliance exploit should raise the risk score for all the internet-facing VPNs. And this bridge the gap between unstructured threat intelligence and structured asset-centric prioritization. So there's a lot to do in this space. But as a starting point, these models can be used to build an asset-centric asset-centric model for vulnerability prioritization. Now, I will go over some of the challenges which we may face during the asset-centric vulnerability management process. So, a data quality can be a big issue if we go this with if we have incorrect data and if we go with this approach. So, if our CMDB or asset inventory is incomplete, duplicated, or outdated, then even the best AI model will produce misleading results. And we won't want that to happen. So, for that, we need to have very good pipelines and very good data quality before we move on to the asset centric approach. Many organizations underestimate how much inaccurate asset data undermines the risk scoring. This is one of the biggest blocker for AI success in security. Next is mapping the complexity. Business impact classification isn't the same across industry or even within the same enterprise. For example, one team may tag application or a vulnerability on an application as a critical, while other teams may see it as a moderate, and it depends on the lens and the usability of that application. So AI depends on the clear labels. So assigning on how we measure business impact is cultural and governance challenge, not only the technical one. So I would like to tell you from my personal experience that tagging on machines is really important. Once we have that data, it is very easy for anyone to grab the business context of that particular asset. And based on it, we can prioritize the vulnerability management and vulnerability patching. And last is the AI explainability. With the increasing use of AI, security and IT teams won't adopt a black box model that simply says patch this first. We technically needs to have more transparency on why we need to patch this vulnerability. So we need more transparency, and model should show why a vulnerability on asset A is prioritized over asset B, whether due to the exploitability chatter we found on a dark web, or exposure level, or asset criticality. So this is very, very important for audit purposes as well. And explainability is not only critical for trust, but also for compliance and reporting. So there are like a lot of rules and audit regulations which we have in place. So we need to have clear definitions on why we are using specific models and why we are prioritizing specific algorithm to prioritize the vulnerability or deprioritize a certain vulnerability. Now, I would like to go over like two case studies from a very famous vendors, which are providing AI-centric solution to small enterprise companies. So, in one of the cases, one of the customers had around 250K vulnerabilities, and using that solution, they combine business context, exploitability data, so they can only focus on vulnerabilities that matters most to them. So they drilled down all the vulnerabilities to just 7 to 8 vulnerabilities, which were very, very important for their organization. And another example, a major manufacturing company using security solution reduced vulnerability by 30% in 6 months, around 243 apps, and reduced remediation time by 240 to 15 days for critical issues only. So if we follow these approaches, if we start using these approaches, definitely we'll see the results on how vulnerabilities can be prioritized and why asset-centric model is much required these days. So just to tell you more context, so these days, whenever we get a vulnerability, attackers have different ways to find a hole or a loophole in your machines and assets, and they usually can do an attack within the same day. Usually, initially, when all this started, right, vulnerabilities used to come, and usually attackers will have 15 to 20 days time frame to attack a vulnerability. So you see, the time frame to attack is also reduced, and attackers are getting more professional and very active these days. So we also need to become more active and with our approaches what we use, and definitely it's time to use asset-centric AI approach. Now I will go over like these are the list of references which were used to gather the data and provide you more information on it. Lastly, I would like to say you all thank you and say that smarter vulnerability management isn't about patching everything. It's about patching what matters the most. Thank you.